What's the current state of AI? Why nowadays everyone seems to be the AI expert offering some kind of AI-based offering? In order to answer all of those questions, I asked my good friend Victor to join me today and hopefully answer those questions for us. Hello, Victor.
Hello, Lucas.
I,
Hello,
I, I
everyone who is watching.
I know that you're in the field for a long time. Could you briefly introduce yourself and uh, explain your IoT machine learning journey, basically how it started and where you are right now?
Yes. So, my name is Victor Jaramillo. I am from Colombia, from Medellin, particularly. Now based in Warsaw, in Poland. And originally, I am a mechanical engineer, and did a PhD in robotics in Spain. And then I moved to Krakow in 2011. And that was where my journey with AI/ML started. Because in those times, almost 12 years ago, there was a project funded by European Union called Energy Smart Operations. And the idea in this project was to address several like work streams related to optimizing operations of factories. And one of the work streams was predictive maintenance. So the idea was to develop techniques to make operations in a factory more efficient. And one of those was to be able to predict failures before they actually occur, so the factories can have a higher, this is, I think it's called OEE, right, which is an indicator of how effective is the factory, how much time the factory is working, and how much time factory is producing. So that was when it started. It was predictive maintenance in ABB. There was a corporate research center in Krakow. Now it belongs to Hitachi. And I was researching on the predictive maintenance of rotary equipment, particularly electric motors, compressors, gearboxes, and so on. So that was it, right? Like I never touched that in my previous jobs or previous studies, but because of the research project, I got to get my hands on predictive maintenance, and that was like it triggered everything and all the things I do now.
Cool. So maybe let's start with explaining fundamentals. So could you give us examples of AI and ML, right? Because people tend to use all of those terms without really understanding them. So if you could give us a very brief intro.
Yes. So AI, I think, is like a field of computer science. Like it's very broad, right? And if you read about the descriptions of AI and ML, it's always going to tell you it's an umbrella term and so on that covers a wide range of techniques. Because not many techniques of AI are require the models to learn something, right? Like we do in machine learning. So in AI, you can have, for example, genetic algorithms, fuzzy logic, neural networks, linear regression, and so on, right? And many of these algorithms, some of them might need some data for the model to learn from the data. And some others just need, for example, the human input. You as human, you define certain rules, and then your AI algorithm can help you to take decisions or to filter information, extract probabilities, and so on. So that's AI, generally. And machine learning, in particular, focuses on algorithms that need to be trained and learned from a data set, right? So then that's when we have these things to classification algorithms, right? To classify labels, or regression algorithms to predict a number, forecasting, right? So I think, like, in general terms, that is the main difference, right? You can do AI without training a model, like for example in genetic algorithms or agents, right? Where you are a human and you put your things based on your experience or in certain rules you want the algorithm to operate. Whereas in machine learning, you have to train your model, have the original data, train your model from the data, and then you will have a model that learned some rules and then apply it to new data.
Okay, perfect. Thank you for clarifying that. So recently, I observed like abundance of companies and solutions based on AI, and I always am curious what's the root cause, right? Because it looks like the whole AI thing exploded. So
Mhm.
were there any theoretical breakthroughs? maybe some new software was developed for AI ML capabilities, or maybe that's purely the hardware power that we've got at our disposal. So, based on your experience, what is the root cause of that AI revolution that we are seeing right now?
Yes, this is a good question, and I think there are several factors. One of them might sound silly, but I think that the LinkedIn, right, and the social networks that are more professional have helped to expose, make more widely known a lot of the capabilities of these AI ML solutions, right? In the past, we didn't have these. Probably CEOs, managers were reading about new technology trends in some websites, in some magazines, and so on. But now we have a massive network where, like it happened to ChatGPT. ChatGPT was launched and it exploded, and I think a lot of it was thanks to LinkedIn, because there the people go to see new things. On the other side, I think like AI has been year after year proving itself to be worth of being used. When I started in 2012 working with these topics, we still didn't have deep learner networks, or like these convolutional networks, the kind of techniques that are used in deep learning. We still had neural networks, normal like shallow neural networks, the common techniques like support vector machine, linear regression, and so on. And I think it was starting to get some traction, but specific applications, right? But I think for one particular thing, there was, I think in US, they had a competition, if I'm not wrong, called ImageNet. And they had the ImageNet data set. And I don't know, it has millions of photos. And the competition was to build a model that was able to classify as many images as possible. And year after year, it was improving. But suddenly one year, it skyrocketed because they implemented the convolutional neural networks. So, it made a lot of news that, wow, an algorithm that can generalize so well and so on. So I think that this kind of breakthroughs that perhaps happen in academia or in more academic environments also made it through mainstream media, and people realize, oh, this is interesting, right? Like perhaps we can apply it. Like it happened, for example, with autonomous vehicles, because that's also another example. Autonomous vehicles have been for a long time, and I think that the root of this was autonomous robots, but tiny robots, right? Like robots this size that have few sensors and can navigate in a maze. Like I don't know, in 2009, 8, I think there was this conference called the DARPA Challenge, where DARPA, this agency for US, was giving $1 million to the university that was building a robot that was able to navigate through the desert without getting lost and reaching specific checkpoints. So the teams, robotics teams, people that never use the car, they use a small robot to navigate unknown environments. They set up a car to do this navigation first on the desert. Then the next year, they did it, but in the city, in a particular sections of the city where there were traffic lights, etc. So it was more challenging. But then they noticed that, okay, these things can be used for real applications, not for other car in the desert. So then it gave the jump. Many of the people that work in this DARPA challenge started to work in Waymo, this company from Google that is building autonomous vehicles. And I think that from there, the topic exploded also, because many companies were like, okay, this can be done, right? AI has given us an edge here, and we just need to build it. And that also has given, like they started to take people that were working in these projects or working in these competitions to build their own autonomous driving solutions, right? So I think that, yeah, it's a combination of factors, right? And last but not least, indeed, the newest and more powerful computing capabilities has also enabled the appearance of these things, right? Because a few years ago, GPUs were not so heavily used for machine learning. I think like people was perhaps aware of their capabilities, but it was not so exploited like nowadays. Now we know all the big deep learning models are trained using GPUs. and not one, like hundreds of them in parallel and so on. So I think that also this has enabled that these initial models that they discover, okay, we know that if we have more data and more bigger models, we can do bigger things. So now it's just a matter of having more hardware and more powerful hardware to scale. So that also has push the
Mhm.
development further.
Yeah, so I think that that's very good point that you brought up. That before the AI was mostly in the academia world, right? Where basically very smart people were doing some research, but only when you mix those researchers with the business-oriented people, then you can see things exploded, right? And that's a universal pattern, for sure, not only related to the AI space, but in the AI space, we can observe it happening right now. That we've got that blend of the business oriented people with like experienced executives, for instance, and very smart researchers building things together. Right? I think that is really good point. And for sure, social media helped to meet those two parties, right? And to interact with each other. So you said that when you started, the AI landscape was a bit different than nowadays. So what would you suggest to someone just starting the AI ML journey? Like, should they start from the very basics, like learning the foundations, um, like some theory, or they should jump straight into most recent tools to learn them? Like, what's your point? How to become the AI ML engineer in your opinion?
This is a good point. And I think like now this topic has exploded to a point where it depends on what you want to do. Generally, from my point of view and what I like to do things from scratch because then I understand how everything works. And then if needed, well, I can use pre-trained models or it doesn't matter. But because I know how to do it from scratch, then it's easier to understand when I am implementing other things that perhaps are pre-existing models or um, libraries that make easy the things, but I know how it works. So that's how I started, right? Like I took an online course with now it has evolved a little bit, I think, in Coursera actually. It's the machine learning course taught by Andrew Ng. He was at those times in Stanford, if I'm not wrong, and that was amazing course. It was covering. It was focused mostly on neural networks, right? But also they cover other different techniques for machine learning, like support vector machines and nearest neighbors, principal component analysis, and so on. So that was a very interesting course because it goes deep. You understand the root of the things, but still, it's not that you're gonna get lost in the math, right? You understand how to implement things from scratch, and then you can understand how to use a library that implements the things for you. So it makes it easy. So that, let's say for me, I would recommend someone that wants to be heavily invested in the topic, start there. One of these machine learning courses from Coursera, given by Andrew G, I think they're really worth the time.
And
And
what do you think about the math? Like, how deep into the math and the theory one should go?
this is
Because
good.
not everyone is like experienced mathematician, like with a university degree in abstract math, for instance, right?
Yes,
So
this is a good point.
yeah.
One thing is that when you learn this, do these courses, you're not really you have to be honest. It's not that you are going to become an expert in this and you are going to be able to create your training algorithms from scratch or new theories. No. You will know how to train a neural network, to build a basic neural network or a deep neural network and so on. But you will not be qualified as a deep a researcher because I think for to be a researcher and to come up with ideas for new architectures and things, it requires a lot of understanding and probably a master's or a PhD. But we are not going there. We are going more on the implementation side, where you know the basics, you know how the thing works, and you know how to adapt it for a particular business use case. So if that's what you want, you don't need to learn so much math. In the courses, you typically learn a couple of things like do a review of linear algebra and a little bit of calculus, and that is enough, right? Because you don't go so deep there. And so I think that should not be something to be afraid. And actually, in the course, Andrew clarifies to the students, like, don't worry if you don't understand this thing. I will explain it simple, and then he actually simplifies the thing, and then you can move on. You really don't miss something if you don't understand in detail all the
Mhm.
things.
Cool. So in that case, what is the most important skill for someone who wants to be a machine learning engineer? Because you said that we do not have to got the university degree in math, right?
Mhm.
So what is the core skill that is relevant?
I think, you know, there is in data science when you are building models, but there are many skills important, right? Like, but I think some are less radical than others because you can be super good coding, making your code structure, reusable, portable, whatever, but you have no clue how to analyze data. And I think for machine learning itself, it's better if you are good analyzing data. That because right, when you're building a machine learning model and with neural networks or with other techniques, SGBoost and so on, the most important part is the data analysis and the data preparation, right? It is said most of the cases is 80% of the time you spend it preparing your data and in feature engineering, and the remaining 20% training the model. So that initial part, data preparation, is where all your analytical skills are needed, right? That you can understand how your data can be related with the business use case that you are taking care of. For example, when I was interviewed to work in Amazon, I was given a data set of some equipment that was failing. And there were a lot of features. It was tabular data with different features and some values and dates. And for me, one of the interesting things, and that I noticed that many people fail when we do the interviews, is to use, for example, the dates and timestamps when they are doing the analysis. Often people say, this is not needed. But turns out that if you analyze the dates, then you discover patterns, right? Like a failure is happening mostly Sundays in the evening or on Wednesdays at noon. These kind of patterns can lead you, okay, so what's going on? Then you can ask business side, what's happening at these times? It's because there is change of operators. Right? Okay, so you discover underlying information that was not in the data set, and it can help you to, build a model that is more sensible to the data and can help you predict things faster. So I think that this is something that has to be cultivated if you want to be a good machine learning engineer. Is this analytical skills, like to know how to analyze your data to extract value from it, and then once it's like you have interesting features extracted, you can give it to a model so the model learns the different patterns and can make easier predictions. And then on top of that, well, of course, learning to do proper coding, right, to write software properly, that keep it reused, can be ported and organized, right? Not the long, how is it called? In Spanish we call chorizo, it's like a spaghetti code, right?
Mhm.
That you have one function that does everything and then impossible to maintain and so on. That also is an important thing once you're going to the, okay, you build a model and you want to use it in production, but you need these additional components.
Mhm.
So
Yeah, so I'm glad that you brought up the equipment monitoring example, because this is actually my next question. As you know that I'm from the IoT space, where do you see the biggest potential of AIML if it is executed at the edge devices, like directly, where the data lives, or maybe it can give us better outcomes when we execute those models in the cloud when we've got basically unlimited computation power, right? So where do you see the biggest value, and what is your prediction of how the whole thing will evolve in the future?
yeah, I think this is a very interesting topic because now after the explosion of ChatGPT, we have seen that yeah, everybody uses it, but if you check how much power it consumes to run a query on ChatGPT, how much water it consumes, the people is like shocked, right? And also I read that for I think for Microsoft that they launched this code pilot, copilot for coding, that they are losing $10 per user. Imagine. So they are realizing that all these AI solutions are actually more expensive than they thought initially, and they have to figure out how to market it, how to sell it to make it profitable. Because to run all this massive infrastructure costs a fortune, right? So, and also the environmental impact that this can have, because companies will claim, we are green, etc., but then you are consuming hundreds of liters of water per query for ChatGPT. So the servers are on fire all the time, right? So I don't know if this will raise concerns and the paradigm will change, right? This might, let's say, lead to okay, a more controlled use of the cloud usage for the models. But in addition, I saw that, for example, I think it's Apple that apparently in the newest phone, they are running models in the phone itself. I think it's the Qualcomm chips that have, like, they can run their own models as well, like we can run machine learning. And I think that might be a way to, let's say, slow down a little bit the consumption of cloud and then transfer it to edge devices like their cell phones, right, or other sensors, which might make more sense, right? You will consume less cloud. You don't have to be streaming data all the time. You can do it everything inside your device. And as long as the devices increase their computing power and capabilities, I think that this might be the case, right? Where you will have a device that has been trained with your own data. So it just receives, let's say, pre-trained model from the cloud, from the manufacturer, and then is over time is improving, and getting better with your own data, with some reinforcement learning. And I think that might be the future, right? Like a mix of both, with a more focus on edge devices.
Mhm. Yeah, I believe that usage of edge devices also answers the security and privacy question, right? Because if your data stays on your phone, let's say, and it's not sent to any type of backend, then like I believe end users will be more willing to use those solutions because they know that they own the data, right? And the data it doesn't have to be sent anywhere else for them to get the outcomes, right? So I think that is a great point that you brought up, and hopefully we will move further into that direction because in the IoT space, I also see the huge push for the edge, and the privacy is one of the leading forces that actually make architects and developers try to leverage edge computing as much as possible. So I've got the most interesting question at the very end for you. So, what is the current state of maturity of AI? Because I played with ChatGPT, I played with other tools, and on the high level, it looks like they are working just fine. But when I tried to make them do something very specific, they failed most of the time. So, what's your take on that? Like, do we see the hype, or if there is some level of maturity like somewhere hidden behind the hype that we are seeing right now?
This is also a very interesting question, and I think that unfortunately we still have a hype on things. I think there will be, I will let's say, tell the question in different times. First of all, like right now it's a million startups. No, like large language models, all these kind of things. Probably in a couple of years or 1 year there will be a bubble, right? All these overvalued startups will go bankrupt, and then only few survive. And these are the ones that are going to drive innovation in the AI in the next few years, right? But that is also the thing that it means that the technology is still not mature, right? And there is an underlying cause that people ignore, is that companies are not data ready, right? It happens often that, no, I want this, etc. They say, okay, show me your data. The data, they have million databases. They don't, they are not doing, they don't have data governance, right? They don't know, they need data from one database, so they have to look for the owner of the database. They say, give us access to the data. They make it up, make a dump, right? You cannot even connect to the database with some ingestion mechanism or something. And this kind of situations, right? So I think that this is the big problem. Like, even though if you have your own data and let's say that you can fine tune one model and it will work for you, one of the biggest problems will be always your lack of governance of the data, right?
Yeah.
So, and I think that that's a problem because it's a boring topic. Nobody wants to talk about data governance. Like, it's like, oh, no, I want the
Yeah, but
nice
but but
next
but,
next.
but then we've got the common issue that we've got garbage in, garbage out, right? Like those models cannot give you good quality of outputs if you feed them with really poor quality of input data, right?
Yeah, I saw these days, like some memes in LinkedIn, like, oh no, our data is good. Show your data. Then it has like a lot of the name of the same city, but written in like a five, six different ways, with capitals, with lowercase. It's like when your data looks like this, it's a mess, right? And also another thing is sometimes there is lack of data, right? When you want to train your own LLM or things like that, you need millions of samples and label samples and so on. And sometimes companies don't have it because they never thought that they will need it. So this is the issue, right? Like the problem is that the social media, LinkedIn, creates such a lot of hype and high expectations that are very far away from the reality of companies with regards to the data. The data, because the data is the core of whatever. I was discussing this today with colleagues in the office that the AI, I think OpenAI, the main thing that nobody talks about is like how they get their data. Because they did an internet dump, yes, but you have to label it, you have to clean it. So imagine all the effort you have to do to clean petabytes of data of all the internet, like to remove things that hate or pornography or things that are illegal. It's an insane effort, and I think that's where the secret is. And yeah, I think we might see in the following years some applications that become successful and so on, and let's say try to show that the technology is mature and can be for some cases, but still, as long as the data readiness of companies is an issue, the AI will not reach its maturity, right?
Hmm. Yeah. So once again, like bringing my IoT perspective, that's very the same case in my domain because sometimes we've got a case where we've got some readings from sensors and we send those readings to the cloud, let's say, um, and if no one really verifies if those readings makes any sense or not, right? Then we can just send garbage data into the backend system because the sensors are totally, not calibrated for sure. And that's the same case as you said, right? If we want be very careful with the initial setup, with labeling data, with verifying the quality of data that we are working with, like using all of those shiny new technologies will not do any good, right? Without that boring day-to-day work that everyone is, like everyone hates it in a way, right? But if someone wants to really provide a value, they need to be ready to get their hands dirty and basically
Yeah.
do this kind of stuff.
Yes. It's that you know, say better they have to get their hands dirty, and then they can exploit their data and yeah, flourish with AI.
Cool. Okay, Victor, thank you very much for joining me. How can people reach out to you to learn more about AIML and ask you some questions?
You can reach out to me in my LinkedIn. I am, yeah, thank you for sharing this link. Yeah, happy to answer questions and connect. I have few people in the past that connect with me randomly, just asking things or just because they were curious of how it was working in AWS. So happy to answer questions and connect.
Cool. So, on that note, Thank you, Victor, once again for joining me. Thank you, everyone, for
Thank
attending
you.
today's meeting. Till next time. I'm Łukasz
Thank you.
Malinowski, the Internet of Things Advisor and Trainee. Bye bye.
Bye bye.